Hello friends, today we are going to study about energy molecules. So what are energy molecules? Energy molecules are the molecules that releases energy or that provide energy. Now why these molecules can provide energy? Because they contain energy rich bonds. What are energy rich bonds? Energy rich bonds means these are those bonds which have energy of equal to or more than -7 kilocalorie per mole, or in kilojoule per mole if we say it is 28 kilojoule per mole. So energy molecules are the molecules that can provide energy. And why they can provide energy? Because they contain energy rich bonds whose energy is should be equal to or more than -7 kilocalorie per mole or 28 kilojoule per mole. Now these energy rich bonds, when they are broken down, they provides energy. In our biological system, we have many energy-rich compounds that contains energy-rich bonds. What are those? PP, carbonyl phosphate, 1,3-biphosphoglycerate, ATP, phosphate creatine, etc. Similarly, there are few compounds which are known as non-energy rich compounds. That means they cannot provide energy because they don't have sufficient negative delta G value. To be an energy rich compound, the minimum requirement is delta G should be -7 kilocalorie per mole. Minimum. If it is more than that, it is very good. If any compound has bonds whose delta G value is less than -7 kilocalorie per mole, then those compounds cannot act as an energy donor, or these compounds cannot provide energy to our body. Now, the energy currency of the cell is ATP. Why ATP is the energy currency of the cell? Because ATP can dissociate into ADP plus Pi with the delta G of -30.5 kilojoule per mole, and ATP can also dissociate into AMP plus PPi with delta G of -45 kilojoule per mole. That means ATP dissociates into ADP with the release of 1 phosphate. During that time the delta G is -30.5, and ATP can dissociate into AMP plus PPi, that is release of 2 phosphate, and the delta G value is -45.6. Because it has delta G value much greater than -7, hence ATP acts as an energy currency of the cell, or ATP can donate energy with the breakage of phosphate bond, phosphoanhydride bond. If you see the structure of ATP, consists of 3 phosphate. ATP, triphosphate. So it consists of 3 phosphate. When it releases 1 phosphate, the energy released is -30.5. When it releases 2 phosphate, the energy releases -45.6 kilojoule per mole. So an ATP dissociates or releases phosphate, either single or double, both having very high negative delta G value. Hence ATP acts as an energy currency of the cell. Now, the dissociation of ATP. What are the factors that favors the dissociation of ATP? Or what are the factors because of which the ATP can act as an energy currency of the cell, or it can provide us energy? If we see the structure of ATP, ATP is 4 minus. Here you can see in oxygen, this is 1 minus, this is second minus, third minus, and 4 minus. So ATP has 4 negative oxygen. After dissociation, after release of 1 phosphate, now it became ADP 3 minus. So that means first factor that favors the forward reaction is electrostatic repulsion. If we compare ATP 4 minus and ADP 3 minus, among these two, which will have more electrostatic repulsion? Definitely 4 minus, because it has 4 negative oxygen. So repulsion will be more in ATP compared to ADP. So electrostatic repulsion is the first factor that favors the release of energy or dissociation of ATP into ADP and PI. Now, second is resonance stabilization. If we see, after dissociation, 1 phosphate is released. So now how we write the structure of phosphate? This how we write the structure of phosphate, right? Instead of writing this, we can also write like this. Instead of putting double bond here, we can keep the double bond here. Similarly, we can also write in this way. All are same, right? It is not necessary that we have to put double bond on the right hand side only. We can put in this position also, we can put in this position also, we can put in this position also, right? This type of structure or this type of arrangements are known as resonance stabilization. Whenever we can write the structure like this, that it is not necessary that we have to keep the double bond here. We can put double bond here also and make it negative here also. We can put double bond here also, make it others negative also. So that means the electrons have space to rotate. Correct. Negative is what? This is electrons. So here in this type of structures, the electrons has more space to rotate around a group of atoms. This type of structures or this type of stabilization is known as resonance stabilization, where it is not necessary that electrons are fixed in one position. When they have freedom to move, that type of stabilization is known as resonance stabilization. Okay, so if we see the structure of phosphate, it is resonance stabilized structure. Hence, this factor also favors the breakdown of ATP into ADP plus Pi. Now, one more element releases H plus. This is stabilized by degree of ionization. Because cell has low H plus, hence the breakdown of ATP, because it releases H plus, the reaction will be favored. Next is stabilization due to hydration. Because phosphate had so many negative oxygen element, hence the water can interact with this negative. The positive part of water, that is hydrogen, can interact with this negative oxygen. So this is known as stabilization due to hydration. So what are the factors that stabilizes the release of energy from ATP, or what are the factors that pull the reaction towards forward direction? First is electrostatic repulsion. If we see, ATP is 4 minus, ADP is 3 minus. So definitely electrostatic repulsion will be less in ADP compared to ATP. Second is resonance stabilization. Because in case of PO4, we can write like this, keeping double bond here. We can also write like this, keeping double bond here. So these type of structures are known as resonance stabilized structure, where electrons have more freedom to move. So this type of stabilization is known as resonance stabilization. Next is degree of ionization. Because here H plus is also releasing, in the cell we have less H plus, so the release of H plus is always favored. So this is called degree of ionization. Next is stabilization due to hydration. Because phosphate has so many negative oxygen element, and in the cell we have water molecules. In water molecule we have again hydrogen partial positive charge, oxygen partial negative charge. So this hydrogen of water can interact with this oxygen of phosphate. So this type of stabilization is known as stabilization due to hydration. Clear? So by seeing the structure formed, by seeing what elements are released, we can say what are the factors by which the reactions are favored in forward direction, or that particular molecule can act as an energy donor for the biological system. Now, ATP provides energy by group transfer. What do we mean by group transfer? If we see this reaction where glutamate is getting converted into glutamine, though when we write in a single step, but actually the step consists of two sub-steps. Here in the above part, we saw that glutamate reacts with NH3 and finally glutamine is formed with the requirement of ATP. But the reaction is a two-step reaction. What is happening here? The enzyme is glutamine synthetase. The enzyme is glutamine synthetase that converts glutamate into glutamine. In the first step, the enzyme is present, which consists of active site. Now in this active site, glutamate will bind. In this active site, ATP will also bind. After that, this ATP will hydrolyze and it gives ADP plus PI. The PI will not release out. It will still remain bound with enzyme. Here glutamate is already there. Earlier it was ATP. Now after hydrolysis, what is bound here? ADP plus PI. This ADP will release simultaneously. So what will remain now? Only this PI, correct? So PI is still bound with the enzyme. Because of this, the conformation of this enzyme will change. It will take some other shape so that now it can bind with NH3. Here glutamate is there. Now NH3 will bind with the release of PI and then it will occur the formation of glutamine. So it is a two-step reaction, not a single-step reaction. So here ATP is providing energy, but by group transfer. Group transfer means it is not like that the bond is broken, energy is released and the reaction will happen. Correct? Whatever released, that is the phosphate, will remain bind to the enzyme. Because of this, the conformation will change and it can now bind NH3 with the release of PI. After this, because NH3 bind with enzyme in close proximity with glutamate, now this both can interact and give rise to glutamine. So this type of mechanism is known as group transfer mechanism. This type of mechanism is also known by ping pong mechanism, where ATP donates this phosphate which remain bound with the enzyme, and when needed, this phosphate is again released out to some NDP to convert it into NTP, and the enzyme will revert to its earlier form. So this is known as ping pong mechanism. Now what do you mean by glowing ATP? Glowing ATP is what we see in firefly. What's the mechanism happening there? The firefly contain a compound called luciferin. Here in the presence of ATP, the ATP dissociates into AMP and PPI, release of PPI. This AMP get attached with this luciferin to form luciferyl adenylate. Now one enzyme luciferase, in the presence of oxygen, what happens is oxidation of this luciferyl adenylate with the release of AMP and CO2. In this process, light also releases as a byproduct, and what forms is oxyluciferin. This oxyluciferin will revert to its original form of luciferin and the cycle continues. This is the reason why firefly glows, because they contains an enzyme called luciferase which oxidizes, or in the presence of oxygen it attaches the oxygen with luciferyl adenylate with the release of light. Because of this reason only the firefly glows. Okay, so this is called glowing ATP. The mechanism here also same. The ATP dissociates into AMP plus PPI with the mechanism of group transfer and the process happens. Okay, next energy molecule of the biological system is PEP, phosphoenol pyruvate. Now phosphoenol pyruvate converts into pyruvate. Now this pyruvate has two forms, enol form and the keto form. In the enol form, the structure is this is the structure of enol form, whereas keto form has the structure of so in case of pyruvate, keto form is more favored compared to enol form because of this C double bond O. This double bond O is much more stable compared to that COH bond. So hence this type of stabilization is known as tautomerization. Clear? What other stabilization factors help in the progress of or the conversion of PEP to pyruvate? If we see the reaction here, PEP 3 minus is giving pyruvate plus Pi. So here 3 minus, here no minus. So that means electrostatic repulsion is more in PEP. Hence, the electrostatic repulsion will also favor the forward reaction or the conversion of PEP into pyruvate. What could be the another factors? Pi. So resonance stabilization, we already learned why this pi is resonance stabilized structure. Because of pi, one more factors come into play. What is that? Stabilization due to hydration. Clear? Because pi has negative oxygen atom. So with this negative oxygen atom, the hydrogen of water can bind. So this is known as stabilization due to hydration. Clear? Plus pi is also resonance stabilized. So we can see how many factors here also. Resonance stabilization also, electrostatic repulsion also, stabilization due to hydration. Along with that, we also found here in pyruvate the tautomerization. Clear? Next is 1,3-biphosphoglycerate, the another energy molecule of a biological system. So this is 1,3-biphosphoglycerate which gets converted into 3-phosphoglycerate. So here also, if you see the reaction, it was 4 minus, 3-phosphoglycerate is 3 minus. So first factor, electrostatic repulsion. The reaction is favored in forward direction due to electrostatic repulsion. Release of pi, that means resonance stabilization and stabilization due to hydration. Release of H plus, that means degree of ionization. Clear? Here in this structure also 1,3-biphosphoglycerate and 3-phosphoglycerate. If you see this part, this is also resonance stabilized. Why? Because here it is written like this. Instead of writing like this, we can write like this also. So here also we can write double bond this side also, we can write double bond this side also. So that means electrons have more space to rotate around. So this type of stabilization is what? Resonance stabilization. Next is phosphocreatine. The same conversion, interconversion of phosphocreatine and creatine. So here also 2 minus, no negativity, electrostatic repulsion. Pi, resonance stabilized also. Pi, stabilization due to hydration also. Clear? Next is acetyl coenzyme. Conversion of acetyl coenzyme A to acetate. Now you have to tell me why this reaction is favored in forward direction, or what are the factors because of which the reaction is favored in forward direction. So this is only your question, that in acetyl coenzyme you have to tell me what are the factors that stabilizes the reaction or that favors the reaction in the forward direction, that is conversion of acetyl coenzyme A to acetate. Do let me know in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.